Hello friends, welcome to our channel. Let's have a look at problem 2364, count number of band pairs. So here we are given a zero indexed or integer array called nums. So here it defines what's a band pair, right? If you have two different indices, and then this inequality holds. So we want to return the total number of band pairs in nums. So here, if you examine example 1, so the output is 5. So here is an explanation. And if you look at example 2, because it's incremented by 1 each time, so the output is 0. So here, the length is bounded above by 10 to the power 5. In other words, the problem size can be very large. So with that said, let's look at the analysis. So here, first, let's look at this requirement. So this band pair, right? Band pair means this. But if you look at the two sides, it's both sides involve both I and J. So in other words, I and J here, I and J are coupled. So here we can actually, this is equivalent to J minus nums J, or you use nums J minus J, the same, right? Nums J minus J does not equal to nums I minus I. But here, mathematically, the equation at line 5 and equation 7 are actually equivalent. But here, so if you look at logic, here I and J are decoupled. So actually this the equation at line number 7 is what we want to use to solve the problem. So here we can consider those indices. We consider the indices such that so I want to consider the complement. In other words, they are equal. So we can regard those pairs as good pairs. Then what we want to return. So the total possible pairs minus the good pairs. Let's go good pairs, right? So here by good pairs and by total possible pairs, I mean the counting, right? So that's it. So, but how do we get those? It's just some simple counting, right? Let me write the code, and in between we are going to explain the logic. Again, here I want to demonstrate how to use data structure to solve problem. Again, here I'm going to use dictionary. So actually, what I want to use is a subclass called counter. Right. So first I'm going to get this information collections default dict. So here I'm just use counter. That will be sufficient. And then I'm going to iterate over the nums. As we are interested in the indices, so I need to use for I y in enumerate, right? Nums. So in this case, what the store will be the count of the element minus the index. So that's incremented by 1. So that's it. So that's the information we need, right? So you can print out D. So for example, for the first example, so for 4, right, you get just 1. For 1, you just get 1. For 0, you get a 2, right? So in this case, the pair computation will be this, because in example 1, the length is 4, right? So the total possible pair is you choose 2 out of 4. That is 4 times 3 over 2. That is 6. And then there are two indices corresponding to same nums I minus j. So the 2, you choose 2 out of 2. That is 1, right? So 6 minus 1, that is 5. That's the return. So now in the generic case, how do we do this? Let me first get the number of good pairs counting. So basically we just need to iterate over the v's for v in d values. So if v is great, it's just 1 or 0. So then you do this operation. You choose v, choose out of 2. That is v times v minus 2 over 2, right? And then you just add this to the in good. But here I want to use if v is greater than 1, because if it's 0 or 1, it just give you 0, right? So here not just the minus 1. So then what we want to do in good, increment by v times v minus 1 over 2. That's it. So then afterwards we just need to return the length of nums times length nums minus 1 over 2. So minus in good. So that's the count for the bad pairs in the sense of this problem. Let's do a quick run. It passes the 2 test cases. Now let's look at the generic case. It passes all the cases. So here actually I wrote with some redundancy. So for example here you can also just see, you can comment this out and just use this one line. That will be enough. You can submit the same thing. So but personally I would prefer to have this, because logically it's clearer. So with that said, I guess that's about it for the current video. Thank you for watching.